Welcome back to participants. Now we are starting the first session of the workshop, Parametric Statistical Test and its Applications by Dr. Thomas Felix. We are very happy to invite Dr. Felix sir to take over the session. Over to you, sir.
Thanks for the brief introduction. Hope I am audible as well as my PPTs are visible. Am I audible?
Yes, sir. You're
Yeah,
audible.
okay. Yeah, thank you. So first of all, I would like to thank the organizer, so SRM Management, for inviting me as a resource person for this workshop. So as we know that in the first lecture, so around 2 hours, we will be going to see what is meant by parametrical statistical test and their applications. So I'm just starting this. So we know that statistics, what is meant by statistics? So we have to start with statistics. Okay, so then only we will be going into the other parametrical statistics. Okay. So statistics is nothing but, so we know that it is nothing but we have to collect the data. So then we have to process the data. So display the data. So followed by we have to do the analysis. Followed by we have to do the interpretation. So these are all the steps are considered in the case of statistics. So statistics, it will be helpful for collecting the data, which are all the sample designs we are using that can be used. So followed by what are the process, when the outliers are there, then we will remove the outliers. So followed by we will be displaying the data which we have collected. Okay, so whatever we have collected is the raw data. So from that, we have to convert it into processed data. So after that only we will go for displaying the data. So we are having different types of chart and other methods are there for displaying the data. Followed by we will be having the analysis. So for that analysis, so generally before analysis, we will be having a hypothesis or objective. Okay. So whenever we are doing some research work, so generally we will be having some objective. Okay. So for example, so to test the mean difference between male and female. So if this is my objective, so followed by what we will do, so we will frame the research question. Okay, so followed by we will be doing the hypothesis testing. Okay, so hypothesis, generally we will be having two categories. One is null hypothesis, another one is alternate hypothesis. So null hypothesis is nothing but, so based on the objective, so we have to frame the null hypothesis that there is no mean difference, or there is this much amount of mean difference between the male and female income. So the alternate hypothesis is nothing but, so there is a positive mean difference, or there is a negative mean difference between the male and female group. So using these things, so we have to whether we have to accept or reject the null hypothesis based on some statistical test. Okay, so why I am saying these things means, so mainly the parametric or non-parametric test, mainly these things are used to test the hypothesis testing. Okay, so generally the hypothesis testing has classified into two categories. One is parametrical statistical test, another one is non-parametric statistical test. So in the first lecture, so we will be covering the parametrical statistical test. Okay, so in the second lecture, so I think madam will be taking care of this non-parametrical statistical test. Okay, so hope you know the basic thing. Okay, so we why we have to use this parametric or non-parametric test? So mainly for testing the hypothesis, whether we have to accept the null hypothesis or reject the null hypothesis. For that, we have to use the parametric or non-parametric test. Okay, so whether it is parametric or non-parametric, okay, so both the things are used for testing the hypothesis. Okay, so whether we have to accept or reject the null hypothesis. Okay, so now we are coming to the case of parametric test. What is meant by parametrical statistical test? Okay, so here you need to know that, so there is a difference between the statistical test and statistical method. So there is a difference between two things. Okay. So statistical test and statistical method. So in this lectures, so we are going to cover only statistical test. Okay. So I'll tell the difference between statistical test and statistical method. So before that, we have to know what is meant by parametrical statistical test. So the parametrical statistical test, okay, are nothing but it will follow some assumptions. Okay. So generally, so even if it is a OLS or whatever statistical parameters or statistical test we are using, so it will follow some assumptions. So if the test follows some assumptions, then that is said to be the parametrical test. So if that assumptions are violated, okay, so then those are also to be the non-parametrical test. Okay. So I just say, so parametrical test is nothing but, okay, so it will assume that, so it follows the data. Okay, the data follows some specific assumptions or specific probabilities. Okay, so that is said to be the parametrical test. The parametrical test, it involves the parameters. So you need to know the difference between the parameters versus statistics. Okay, so there are two different things are that. The parametrics are nothing but, so it includes the entire population. So I'll be giving an example. So parameters in that sense, okay, what is that? So if I'm taking the average height of doctors in India, okay, so it will represent the entire population. Okay, so it is said to be the parametric. Okay, so on the other hand, statistic or sample, okay, that is different. So statistic or sample in the sense, for example, so I am taking 100 samples or respondents. Okay, so based on the proper research design, so I am taking 100 samples of doctors. So if I measure this those 100 height, okay, so that is said to be the statistic or sample. Okay, so you need to know the difference between parametric and statistic. Okay, so in the case of parametrical test, okay, it involves the parameters such as, so population mean and standard deviation. So as I said that the parametrical test, so it follows some assumptions. What are those assumptions? Okay, so these are the major 4 assumptions. So it will be included in the parametrical test. Okay, so if it is a parametrical test, okay, so it should involve, okay, so if these assumptions are satisfied, then only it is said to be a parametric test. Okay, so first assumption is normality assumption. Okay, so we are saying that the data should be normally distributed. Okay, so we know that there are different types of distributions. Okay, so for example, binomial distribution. Okay, so it is not a normal distribution because it includes only 0 and 1. Okay, so if your data consists of 0 and 1, okay, so then we can't able to use the parametrical test. Okay, so even we can able to check this assumption using SPSS. Okay, so first thing is you have to check whether the data is distributed normally or not. If the data are distributed normally, then only we can able to use the parametric test. Okay, so the first assumption is normality. Okay, assumption that means that the data should be distributed normally. Okay, so we know that how to see whether the data is distributed normally. Okay, so we know that histogram. Okay, so if the histogram is in the bell shape, okay, so then we can able to say that the data is distributed normally. Okay, so you will be asking that whether this is the only way to see the normality. Okay, no. So there are a lot of measures are there. So based on that, we can able to interpret that whether the data is distributed normally or not. So we'll be going to see one by one. Okay, so followed by second assumption. So the second assumption is homogeneity of variance. Okay, so we know that what is meant by variance. Okay, so there is a 2 different categories are. One is measure of central tendency, another one is measure of dispersions. Okay, so measure of central tendency is nothing but it includes only mean, median, mode, and all of the things. Okay, so but in the case of measure of dispersion, okay, it will tell us about the dispersion. So how it is dispersed from the mean? From the mean value, how much it is dispersed? Okay, that can be captured from the dispersion. So within that dispersion, so we'll be having a lot of parameters called variance, okay, standard deviation and all of things. Okay, so in the homogeneity test, it will test about the variance between the two groups. Okay, so when we are having two groups, okay, then only we have to use this assumption. Okay, so otherwise defaultly, okay, it will be rejected. Yeah, Bhatia, you have raised your hand. Shall we have the presentation or else shall we have the discussion?
Sir, we will have the discussion after the end of the
Yeah,
session, sir.
fine.
You can continue, sir.
Yeah, thank you.
Thank you, sir.
So as I said that, so the homogeneity test of variance is nothing but it will calculate the variance are equally distributed among the two groups or not. Okay, that can be captured from the homogeneity of variance. Okay, so followed by, so we are going to see whether the data is independent of the observations or not. Okay, so for example, in the case of time series data, okay, so in the case of time series data, for example, today's tomato price, okay, is depends on the yesterday's tomatoes price. So generally we will be writing it as, okay, T is the function of T minus 1. Okay, so today's price is based on tomorrow's price. Okay, so if in that case, we can't able to use this parametric test. Okay, so the data should be independent of the observations. Okay, for example, if persons are copying, okay, so my mark is depends on the person who is next to me. Okay, so on the other hand, there is no group marking. So each observation stand alone. So then only we can able to use the parametric test. Okay, otherwise we can able to say that this assumptions will be violated. Okay, so independence test or independence of observation is nothing but the data should be unique. Okay, so then the fourth assumption is nothing but interval or ratio of assumption. Okay, so it is nothing but generally the data can be classified into the data scales can be classified into 4 categories. Okay, so the first category is nothing but, okay, so nominal, ordinal. Okay, the data has classified into major 4 categories. Okay, so nominal, ordinal. Okay, so then interval, and finally the ratio scale. Okay, so the nominal, so generally we will be saying these two are qualitative data. Okay, so for example, the nominal data, so if I am using some if I am measuring the gender category, okay, male and female. Okay, so I may be ranking it as 0 or 1, okay, 1 or 2, whatever it is. So then ordinal ranking is nothing but, so if I am using some scale, Likert scale, so if I want to rank it from 1 to 7, okay, so like from not at all good to not at all bad. Okay, so if I am having a ranking, okay, so then these two are said to be the qualitative data. So if the data are nominal or ordinal, okay, then we can't able to use the parametric test. Okay, so but if your data is a interval data or ratio data, so interval in the sense, okay, so for example the temperature, okay, so it's a kind of interval data. So ratio data, okay, it may be a continuous data, for example age, okay, so education, whatever, so age, income, okay, so other things are said to be the ratio. So if your data is an interval or ratio, then you can able to use the parametrical test. Okay, so hope you understand. Okay, so if your data follows the these 4 assumptions, then only we can able to use the parametrical test. Okay, so first assumption is normality, second assumption is homogeneity of variance, third assumption is independence of the observation, fourth assumption is interval or ratio scale. So when these 4 assumptions are satisfied, okay, then we can able to use the parametrical test. Okay, on the other hand, so if your data having only one group, okay, so then automatically, so this assumption homogeneity of variance, okay, will not be applicable, okay, for doing the analysis. Okay, so now we are moving to one by one. Okay, how to check the normality assumption in the SPSS. Okay. So if I am having a data, how to check the normality assumptions? Okay. So we know that the data should be distributed normally. Okay. Then only we can able to say that the data is normally distributed. Then I can able to use the parametric test. Okay. So how to do it in the SPSS? Okay. So I'm just discarding. Okay. So I'll be sharing this sample data with you. Okay. So for example, I am having some data. Okay. So before starting, I have to check the assumptions of first assumption, that is called normality assumption. Okay. So how to do it in the SPSS. Okay. So for example, I am having a variable called miles per gallon. Okay. That is MPG. Okay. So for example, I am going to select only one. Okay. So first I have to open the SPSS. So firstly, I'm going to check the normality assumption. Okay. So when you are opening the SPSS, you will be having two different windows. One is data view, another one is variable view. Okay. So I'm just going to the variable view. Okay. So I'm going to type a variable called MPG. MPG is nothing but miles per gallon. Okay. So I'm having some car data. Okay. So it is not a time series data. Okay. Individual cars data. So according to that, I have collected its miles per gallon. Okay. So if I'm putting some 1 liter, how much mileage it will give. Okay. So here I am just opening the thing. So I'm just copying the entire data. Okay. So then what you have to do, you have to go to the data view. Okay. So here you can able to see that the variable has created. Then I am just pasting the values. Okay. So here what we have to do, first we have to test the assumptions of normality. Okay. How to check the normality assumption. Okay. So in the Excel, I have mentioned that first we have to go to analysis, descriptive statistics and export. Okay. So for example, what I'm going to do, I'm going to click the analysis. Okay. So then descriptive statistics. So within the descriptive statistics, okay. So you have to click the explore. Okay. So then you have to select the variable. Okay. MPG. Okay. So here you will be seeing a lot of statistics will be given. Okay. But what you have to do, you have to click the option. Okay. Yeah. So you have to click the plots. So within the plots, you can able to see the histogram. Okay. As I said that generally we will be using the histogram. Also this normality plot test. Okay. It will tell us about whether the data is distributed normally or not. Okay. I'm just clicking continue. Okay. And I'm clicking OK. So now you got the results. So as I said that to check the normality, firstly, you have to check the test of normality. Within that, you will be having the Shapiro-Wilk test. Okay. So when the Shapiro-Wilk test is insignificant, okay, then we can able to say that. So insignificant means we have to accept the null hypothesis. Okay. So here the null hypothesis is nothing but. Okay. So the null hypothesis is nothing but. Okay. So the data is distributed normally. Okay. So here you can able to see that the probability value is 0.329, which is less than 0.01. Okay. It shows that it is insignificant. Then we have to accept the null hypothesis. The null hypothesis is nothing but, so the data is distributed normally. Okay. Also, you can able to see the histogram. Okay. So even though it is not looking like a bell-shaped curve. Okay. But it is not the only criteria. So first criteria is test of normality. It says that the Shapiro-Wilk test says that it is insignificant. That means that we have to accept the null hypothesis. Null hypothesis is nothing but that is the data is distributed normally. Okay. So secondly, you have to see the normal QQ plot. Okay. So this distribution is should be around the line. Okay. So here you can able to see that the data has distributed around the line. Okay, it shows that the data are distributed normally. If it is far away from this line, then we can able to interpret that the data is distributed non-normally. Okay, so that is the assumption. Okay, so now we can able to pass this assumption. Okay, so now the test has passed this assumption. First assumption, the data is distributed normally. Okay, so I'll just show it in the Excel, sorry, PPT. Okay, so here to test the normality test. Okay, so normality is nothing but the data is distributed normally or not. Okay, so for that we have to do in SPSS, go to analysis, descriptive statistics followed by explore. So then you have to do click the option. So within the option you have to select the histogram and normality test. Okay, so then you have to see the histogram. Okay, it should be in bell-shaped distribution. Okay, so then it is following the normality distribution. Other thing, QQ plot. Okay, this is more important. Okay, so because even though the histogram is difficult for doing the interpretation, you have to depend on the QQ plot as well as the Shapiro-Wilk test. Okay, so as I said that the Shapiro-Wilk test is insignificant. Okay, then it is said to be the normally distributed though. Okay, so as I said that the best practice is nothing but, so we have to use the plot first. Okay, that is QQ plot. Okay, you have to use the QQ plot. Okay, not only based on the p values of Shapiro-Wilk test. Okay, so this, okay, so the data should be distributed. Okay, so around the line. Okay, so if it is distributed like this, okay, then we can able to say that the data are not distributed normally. Okay, so that's what this is a major thing. So we will be having a question. So if the data is not normally distributed, okay, what we have to do? So that is the next question. Okay, so if the data is, if your sample is less than 30, okay, so then you have to check for the skewness. Okay, so if the data is skewed or if more outliers are there, okay, then we can't able to use the parametric test. So we have to go for the non-parametric test. On the other hand, so even though if your data is not distributed normally, okay, but your sample, that means that the observation is greater than, okay, or equal to 30, okay, then the central limit theorem, so it will take care of the normality assumptions. Okay, so you don't need to worry about this normality assumption when your observation is greater than or equal to 30. Okay, so only consideration is when your observation is less than, okay, 30. So then we have to look into this assumption. Okay, so very consciously we have to look into this assumption. So now we are moving to the homogeneity of variance. Okay, so generally it can be tested using the Levene's test. Okay, so as we have mentioned in the case of normality assumption. Okay, so the normality assumptions we have used the case of Shapiro-Wilk test. Okay, so similar to that, in the case of homogeneity of variance, okay, we will be using the Levene's test. Okay, so for testing the homogeneity, whether the data are distributed, okay, the variance are distributed homogeneously or not. Okay, that can be tested from the this test. So here you need to note that if you are having only one sample, okay, so for example in the case of MPG, okay, so I am having only one MPG. Okay, so I don't have any groups. Okay, for example, I am having, if I am having two groups, one is foreign car, another one is domestically manufactured cars. Okay, so if I am having two groups, then I can able to have this homogeneity of variance assumption. Okay, otherwise we are not defaultly we can't able to use this variance homogeneity of variance assumptions. Okay, so I'm going to check the homogeneity of variance assumption. But when you are having only two groups, okay, so if you are having only one group, you can't able to apply this assumption. Okay, when you are having two groups, then only you can able to do the assumption checking. Okay, so how to do this assumption checking? So before that, I just want to say that generally two ways are there. Okay, so in SPSS, okay, so to check the homogeneity of variance, okay, so either we have to go for ANOVA test, okay, or we have to use the t-test, okay, to check the assumptions. Okay, so I'm going to show so I'm going to use the t-test. Okay, for checking the homogeneity of variance, I'm just closing this one. Okay. So I'm going to open the SPSS again. Okay, but in this case, okay, so I can't able to use only one variables. Okay, so if I'm having two variables, okay, then only I can able to use this assumption. Okay, so otherwise we can't able to use this one. For example, I'm going to use the data. Okay, two samples. If I am two groups, one is treated, okay, another one is MPG. Okay, for example, as I said that this is the variable view. So here I am typing, okay, so miles per gallon, MPG. So followed by I'm going to type the type. Okay, so type of the car. Okay, whether it is domestic or imported cars. Okay, so we know that the type. So as I said that the measures has classified into different categories. Okay, so if it is scale, then scale it includes the ratio as well as the interval. Okay, so if it is a nominal or ordinal, we can't able to use the parametric test, but to show the two different groups, we are using the ordinal one. Okay, so nominal. Okay, so nominal means okay 1 or 0. Okay, so I'm going to see the data view. So here I am going to copy the data and I am going to paste the data. Okay, just copying and I'm pasting here. Okay, so once it was pasted, okay, so if you click here, okay, so if you have to go to analyze data. Okay, so if you see here, so first you have to go to analyze. Comparing means, okay, independent sample t-test. Okay, so or you have to use the one-way ANOVA. Okay, so for testing the homogeneity assumption. Okay, so analyze. Okay, so compare the means. Okay, so one sample t-test. Okay, sorry, not one sample t-test. You have to go to the independent sample t-test. Okay, independent sample t-test. So here you have to click the test variable, that is miles per gallon. Okay, so here you have to click the grouping variables. Okay, so I'm having two different groupings. Okay, one is 0, another one is 1. Okay, so I have to define the variables. Okay, one is 0, another thing is 1. Okay, so once I have to click OK. Okay, so then you have to click OK. So here you will be seeing the result of, okay, so as I said that, so at the starting, so for testing the homogeneity, we have to depend on the Levene's test. Okay, so in the case of normality assumption, okay, we have to depend on the Shapiro-Wilks test. Okay, so here you can able to see that the Levene's test is insignificant. The value is 0.855. Okay, so if the variable is not significant, okay, we have to accept the null hypothesis. What is the null hypothesis? The null hypothesis, the data is distributed homogeneously. Okay, so automatically the assumption has satisfied. Okay, so this is with regard to the assumption of homogeneity test. Okay, so now we have used two different tests. Okay, so like assumption test. Okay, so third one is independence of observations. So independence of observation, that means that the data should be distributed, okay, so independently or not. Okay, so for example, t is the function of t minus 1. So in that case, we can't able to do. Okay, so the data is distributed independently. Okay, then only we can able to use the independence of observation. Okay, so far I just want to give a summary. So first one is we have seen the normality assumption. Okay, so second one is we have seen the homogeneity of variance. Okay, so now the remaining two things are so third one is we have to see the independence of observation. Okay, fourth one is the data should be in the scale. Okay, the scale should be either ratio, okay, or interval. Okay. So for these two things, okay, we are having some test. Okay, Shapiro-Wilk test. Okay, or you can able to use the histogram. Okay, or you can able to use the QQ plot. Okay. Similarly, in the case of homogeneity of variance also, we are having the Levene's test. Okay. So in both the cases, if the variable is okay insignificant, that is okay, so greater than 0.05. Okay. So in this case also greater than 0.05, okay, or 0.01, 0.10. Okay. So in that case, these two are said to be the insignificant. Okay. So we have to accept the null hypothesis. Okay. So now for these two, so we don't have any test, okay, for checking the assumptions. Okay. So it has to be checked, okay, by the researcher. Okay. So we know that independence of observation. So it depends on the design, okay, research design, which you are adopting for your study. Okay. So whether the data or observations are independent or not. Okay. So then the final assumption is that data should be in the scale. Okay. The scale should be in the either ratio or in the interval form. Okay. So it should not be in the nominal, okay, or ordinal. Okay. So then these assumptions will be satisfied. Okay. So that's what in the case of interval assumptions also I said that. So interval example is the temperature. So the temperature generally will be measured in terms of, okay, interval. So if it is a ratio, in that case also we can able to use the parametric test. Okay. So we can able to use the parametric test. Okay. So if these assumption, okay, so either one assumptions, okay, or okay, so are violated, or all the assumptions are violated, okay, so then we can directly move for the non-parametric test. Okay, so it will be taught in the upcoming classes. So I'm going to give a summary, okay, so for what we have seen. Okay, so parametric test is nothing but it will follow some assumptions. Okay, so the data, okay, the data should follow some assumptions. Okay, what are those assumptions? Okay, so normality assumption, the data should be distributed normally. So it can be based on the Shapiro-Wilk test, QQ plot test, and histogram and all other things. Okay, so homogeneity of variance, okay, that can be tested using the Levene's test. Okay, so either we can able to use the one-way ANOVA, or we can able to use the independent t-test. Okay, so third one is independence of observations. Okay, the observations should be independent. Okay, so finally the interval or ratio scale. Okay, so comparing to the non-parametric test, okay, so the parametric tests are more powerful. Okay, so you will be having the significant value, probability value, t value. Okay, so you will be having the significant range and all other things. Okay, so it is more powerful than the non-parametric test. Okay, so you will be having a precise estimates. Okay, so for example, why we have to use the statistics? So for example, here you can able to see that, so the income, okay, so there are two persons. Okay, person one's income is, okay, so 1 lakh rupees. Okay, so on the other hand, so the person B, okay, so his income is 1 lakh, okay, 1 rupee. Okay, 1 rupee is change. Okay, the difference is 1 rupee. Okay, so if you see that, okay, so there is a difference. Okay, but whether it is a statistically significant or significantly different or not. Okay, so that can be tested from the statistical test. Okay, so because here even 1 rupee matters. Okay, so that is a difference. But when we are proving it with statistics, okay, whether it is statistically significant, so the difference doesn't matter. Okay, whether it is statistically significant or not. Okay, so that can be captured from the statistics. So that precise estimate can be captured in the case of parametric test. Okay. So now we are going to see the what are the common parametric tests. Okay. So first is Z test, okay. So T test, F test, okay. So these are the major tests, okay. So in the starting, I have mentioned that. So our lecture is going to focus on the statistical test, okay. So there is a difference between statistical test and statistical, okay. So methods, okay. So the difference is simple. So the statistical test will be used in the case of statistical method, okay. So that is said to be the statistical method, okay. So I will give with an example. So statistical test, okay, generally, so the statistical test, okay, as I said that it will be classified into parametric and non-parametric, okay. So if it is parametric means what are the tests, okay. So generally major three tests are considered as the parametric test. One is Z test, okay. So T test, okay. So another one is F test, okay. So even T test will be classified into three categories, okay. So one sample, okay, two sample, so followed by we will be having the paired sample, okay. So when we are using these tests in the statistical methods, okay, that is said to be the statistical method. For example, correlation, okay. So regression, okay. So we will be using the statistical test in the statistical method, okay. So I'll be showing here. Here you can able to see. So in the case of one-way ANOVA is not a statistical test, okay. So it's a statistical method, okay. One-way ANOVA is a statistical method. So it will compare 2 or 3 means, okay. So mean comparison, okay. In that ANOVA table, you will be having the F test, okay. It is the statistical test, okay. It is the statistical test, okay. Similarly, you can able to see two-way ANOVA, we will be using the F test. Similarly, in the case of simple linear regression, so we'll be having T test and F test. So if you see the results, so you will be seeing T test, F test. Okay. Similarly, if it is the case of MANOVA, okay, so you will be having the F test. So similarly, if it is a case of pattern analysis, you will be having the chi-square test. So you need to know that. So the statistical tests are different from the statistical methods. Okay. So with this brief introduction, okay, so I am moving into the statistical test, okay. So as I said that parametrical test, okay. So since we are going to focus only on the parametrical part, okay. So we know that the parametrical part is nothing but, so it should follow some assumptions, okay. So it should follow some assumptions. So we know that the basic assumptions are normality assumption, okay. So homogeneity assumption, okay. So followed by we are having the. So participants, kindly mute yourselves. Yeah. So homogeneity assumption followed by we have seen the independence and the scale assumption. So if it is only one variable, then this assumptions, okay, will not be applicable. So remaining assumptions will be applicable. Okay. So now if it is parametric test means what are the tests we have to use? Okay. So there are major tests are Z test, okay, T test, F test. Okay. So these are the non-parametric tests. So I am not going to touch the non-parametric test. Okay. So this chi-square test, so generally it lies, even though it is mainly comes under non-parametric test. So even we are using it is under parametric test. Okay. So anyhow, I'm not going to touch the chi-square. So we will be going to see in-depthly on Z test, T test, F test. Okay. So within the T test, there are two categories. One is student T test. Okay. That is so student T test. So again, it will be classified into one sample, okay, and two sample, okay. Followed by we will be seeing the unpaired T test, okay. So because why I'm saying these things means, so without knowing the theory, it is difficult for the understanding, okay. So if you are giving some data, automatically the statistical package will provide the results, okay. But that is not our intention, okay. So you have to understand the theoretical base, so then you can able to apply the same in the practical part. Okay. So now I am moving to the T test. Okay. So based on the inception. Okay. Based on the inception. So the T test was the first. Okay. So it was done during the year 1908. Okay. So who gave this t-test? Okay, William Gossett. Okay, he is the father of t-test, or he is the father of t-distribution. Okay, he is the father of t-distribution. Okay, since he has given this test, okay, due to that we are saying that it is a t-test. Okay, so then as I said that every data should follow some assumption. Okay, so the data should be distributed normally, and also it is based on the t distribution. Okay, t-test is based on the t distribution. Okay, so then we will be having a question when we have to use, what is the need of using this t distribution. Okay, so before that I'll be going to say, okay, why the t-test is saying it as student's test. Okay, so we are saying that t-test. Okay, so why it is otherwise called as student's t-test. Okay, so it is an interesting story. So as I said that who gave this t-test? Okay, so William Gossett, he gave this student t-test. Okay, he is a statistician. Okay, so he was worked in a brew company. Okay, so it's a liquor company. Okay, so based on Dublin. Okay, so the name is Guinness. Okay, so he worked there as a statistician. So he used to publish many papers. Okay, so during the publication, the policy of the brewery is nothing but, okay, so they should not reveal their own name. Okay, so what he did, so he has a fake name called student. Okay, so he published this paper. Okay, so in the name of student, so due to that, so the t-test is called the student's t-test. Okay, so that is an interesting story. Okay, so then we are moving to the type of t-test. Okay, so t-test, so in general I'll just mention it here. Okay, so t-test, okay, z-test and f-test. Okay, so in general, when we have to use the t-test, or what for what we have to use the t-test and z-test. Okay, these two are used for mean comparison. Okay, so if your objective is to compare the means, okay, then you have to use the t-test or z-test. Okay, so if your intention is to compare the variance, then you have to go for the f-test. Okay, so both the tests are called as mean comparison. Okay, so then how to select t-test or z-test? Okay, so it is simple. Okay, so it is based on the sample size. Okay, so if your sample size is, okay, less than or equal to 30 sample, okay, so then you have to go for the t-test. Okay, so if your sample is, okay, greater than 30, then you have to go for the z-test. Okay, so variance is different. Okay, variance is different. That means that, so you are going to calculate the variance between the two groups. Okay, so then the t itself having three different categories. Okay, so three different categories of t tests are there. Okay, so anyhow, the intention of the t test is nothing but, so we have to compare the means. Okay, so on the other hand, so what are the types of t test? Okay, generally three different types of that. First one, second one, and third one. Okay, so first one is one sample t test. Second one is independent sample t-test or two sample t-test. Okay, so third one is paired sample t-test. Okay, so quickly I'm going to narrate. Okay, so what is the basic difference between these three? Okay, so first one is, so as I said that the ultimate aim is to compare the mean. Okay, so ultimate intention is, our objective is to compare the means. Okay, so in the case of one sample t-test, it shows that only one variable or only one sample. Okay, you will be having, so for example, miles per gallon. Okay, you are having only one sample. Okay, so you are going to, so you know the difference between the sample and the population. Okay, so population means entire. Okay, so entire observations are said to be the population. Okay, when you are taking few observations from the population, that is said to be the sample. Okay, so when you are comparing the mean of the population with the mean of the sample, okay, then that is said to be the one sample t-test. Okay, so for example, so India's, okay, so average income, okay, or life expectancy, whatever it is. Okay, so you are comparing that with the you are taking some samples. Okay, so for example, so from each states you are taking few samples. Okay, okay, so then you are comparing this sample is equal to this sample. Okay, so it is also kind of mean comparison, but here you need to know that you are comparing the sample mean, okay, with the population mean. Okay, then it is said to be the one sample t-test. Okay, then independent sample t-test. So independent sample t-test is nothing but, so here two samples will be there, sample 1 and sample 2. Okay, but ultimate aim is to compare the means. Okay, ultimate aim is to compare the means, but here it is not population, it is about the sample. Okay, sample 1 and sample 2, whether these two, for example, it may be male, okay, it may be female. Okay, so I am going to compare the two different samples. Okay, so whether the mean difference of their income is different or same. Okay, that is said to be the independent sample t-test. Okay, thirdly, paired sample t-test. So paired sample t-test is nothing but same sample. Okay, so you are going to check before and after. Okay, so for example, the sample is, for example, 20 farmers you are taking when you are giving some training. Okay, so before training, you have collected the data like what is their yield, okay, or what is their knowledge, whatever it is. Okay, so after the training, you are measuring the same respondent. Okay, so then you are going to check whether the mean difference of the yield is there or not. Okay, so then that is said to be the paired sample t-test. Okay, so now we are moving to the one sample t-test. Okay, so then we will be following the other sample t-test. Okay, so one sample t-test, as I said, that the intention is to compare the means. Okay, so intention is to compare the means. Okay, so you are going to compare the sample mean with the population mean. Okay, so that is the ultimate aim of one sample t-test. Okay, so actually you need to note that the population mean, because we don't know. Okay, so it is difficult for us to calculate all the information from the population. So due to that, we will be having some hypothesis to mean. Okay, so for example, I'll be having some hypothesis that the population income may be some 10,000 rupees per month. Okay, so then I'm going to compare with my sample mean. Okay, so I might have collected some samples. Okay, from 200 farmer or 500 farmer. Okay, then I'll be comparing the population mean with the sample mean. Okay, so whether these are same or okay not equal. Okay, so then as I said that, so we have to frame the objective. So first we have to frame the objective. So objective is to nothing but okay to test the mean difference. Okay, so mean difference between male and female. Okay, so income of male and female. Okay, whether both are same or not. Okay, so first you have to know that whether it is a one sample or not. Okay, so for example, if it is a only one, okay, one category, male only. Okay, so this is the case of I am collecting some hundreds of farmers. Okay, so male. Okay, then I am going to relate with the population. Okay, so male income of India. Okay, so this is my objective. Okay, so we know that it is clear that my objective is to check the means. Okay, so I'll compare the means. Okay, so based on that, I have to frame the null hypothesis and the alternate hypothesis. Okay, so the null hypothesis is okay, there is no difference between the mean among the sample and the population group. Okay, so then, so the alternate hypothesis, generally it will be having two tail or one tail. Okay, so two tail in the sense, so it won't tell about the relation, whether it is positive or negative. Okay, so for example, I'll be putting it as a, okay, there is a relation. Okay, so between the mean income of sample and the population. Okay, so I'm just mentioning that the relation, that is a relation. So I didn't mention that it is a positive relation or negative relation. Okay. So I'm just simply saying that there is a relation. So on the other hand, if it is a one-tailed test means, so you have to specifically mention that whether it is positive or negative. Okay. So accordingly, you have to, so for example, next you have to do the t-test. Okay. Then you have to prove or disprove the null hypothesis. Prove or disprove the null hypothesis or alternate hypothesis. Okay. So this is the formula. Okay. One sample t-test. So each thing has its own formula. Okay. So for example, as I said that it following the t distribution. So what is the formula? X bar minus mu divided by standard deviation of the data, then square root of n. Okay, this is the simple formula. Okay, so what is the formula for standard deviation? Okay, so standard deviation is nothing but square root of summation of x minus x bar whole square divided by n minus 1. Okay, so we know that there is a relationship between the standard deviation and the variance. Okay, so square root of standard deviation is nothing but variance. Okay. So I don't want to go in detail of this mathematical expressions. Okay. So I'll be going to show how to run the one sample t-test. Okay. So before that, you have to check the assumptions. Okay. So whether it is normally distributed. Okay. So we know that it is based on the Shapiro-Wilk test. Okay. QQ plot and histogram. Okay. Similarly, homogeneity test. Okay, so homogeneity test will not be applicable. Okay, in the case of one sample, okay, one sample t-test. Okay, we will be having only one sample. Okay, so if you are having more than one sample, then only we can able to see homogeneity of variance. Okay, so homogeneity of variance can be captured only. So homogeneity of variance can be captured only the sample are more than 2. Okay, so then independence and the interval ratio. Okay, so I'm going to show it in the I'm just discarding. Okay. So I'm just opening the SPSS. Okay. So once you have opened the SPSS, okay, so I'm going to see the data. Okay, so this is the data, miles per gallon. I'm having the data. Okay, how many observations? So I'm having 30 observations. Okay, so if the observations are 30 or less than 30, so then you can able to use the t-test. Okay, so instead of z-test, directly you can able to use the t-test. Okay, so once you have opened the SPSS, okay, so you have to type the variable name. Okay, I'm having only one variable called miles per gallon. Okay, so this is the sample mean. So I'm going to check the sample mean with the population mean. Okay, so I'm having an assumption that the population mean is somewhat 20 miles per gallon. Okay, so the world population or the India's mean is, okay, population mean is 20. I'm going to check the mean difference. Is there any difference between my observation, that the sample mean is different from the population mean or not? Okay, so for that I'm going to copy and paste the data. Okay, so I'm just copying the data. Okay, so and I am pasting the data. Okay, so once you have pasted the data, so you have to do the basic assumption test. Okay, so for the time being, I'm just directly going to the analysis. Okay, so here you will be having different things. Okay, one is comparison of means. Okay, mean comparison. Okay, so as I said that, so the t-test and z-test are mainly for mean comparison. Okay, so within that we will be having the one sample t-test. Okay, so I'm just selecting the test variable. Okay, so here you have to so the intention of one sample t-test is nothing but, so we have to check the sample mean with the population mean. So population mean is hypothesis mean. So I am just hypothesizing that the India's miles per gallon of cars will be some 20. Okay, I am going to check that whether my sample mean is different from the population mean. Okay, hypothesis population mean or not. Okay, so I'm just clicking OK. So here you will be having the results. Okay, so mainly so even you can able to copy this one and you can able to run using the syntax also. Okay, otherwise you can do it as a menu driven. Okay, so now we are going to see the results. Okay, so once we have done the result, so how to export the data? Okay, so you can click the file. Okay, export. Okay, so here you can able to see different formats are there. So accordingly you can export. Okay, so for example, I am going to save it in the Excel. Okay, so where I have to save, so I have to say I am just saving it in the desktop. Okay, so I am just mentioning 1P. Okay, so then you have to click OK. Okay, it will take some time. Okay, then you can able to see the data has saved. So ultimately, okay, we are going to discuss the results. Okay, so here you can able to see that. So number of observations. Okay, the number of observations are nothing but it is 30 observations. Okay, 30 observations. So what is the sample mean? Okay, so sample mean is 19.333. Okay, so hypothesis mean or population mean. I have mentioned 20. Okay, so in general, okay, if you are asking that, so is there is any difference between the sample mean and the hypothesis mean? Okay, but that is a difference. Okay, so there is a difference, but it is in very minimal. Okay, for example, it may be 0.64 something. Okay, because 20 minus 19.33, so you'll be getting less than 1 value. Okay, so how to check it in the SPSS? So it is based on, so you can able to see the degrees of freedom. So the t-test, okay, follows the n-1 degrees of freedom. Okay, so n-1 is nothing but the 30 minus 1, which is equal to 29. Okay, followed by significant. Okay, so here you can able to see the mean difference. Okay, so this 19.33. Okay, 20 minus 19.33. So that is the mean difference that was given. Okay, significant or not. Okay, so the ratio, here you can able to see that it is mentioned as two-tailed test. Okay, two-tailed. Okay, so two-tailed means, as I said, that it will be saying that the alternate hypothesis will be saying that there is a relation. Okay, it won't say that it is whether it is positive or negative. Okay, it won't say whether it is positive or not. If it is saying that it is one-tailed. Okay, so otherwise it is a two-tailed test. Okay, so this is the significant value of two-tailed test. Okay, so then we will be how to interpret this one. Okay, so here the ratio is less than 0.01. Okay, or so if you are typing it in if you want to interpret in terms of percentage, that is 1% is error can be allowable. Okay, so error, okay, 1% may be allowable. Okay, in the case of social science, okay, we are having 5% also. Okay, so for example, so I am checking this results. Okay, so then 5% of error is acceptable. Okay, but in the case of medical science, okay, generally they will be considering only 1%. That is 99%. Your results should be correct. Okay, so how to see the significant? Okay, the simplest way is, okay, so you have to check the error percentage. Okay, the probability of error. Okay, so if you click the percentage, okay, it is showing 46% of error. Okay, so automatically, okay, we can't able to say that there is a significant difference between the population mean and the sample mean. Okay, so even though there is some difference, the mean difference is somewhat minus 0.66. Okay, but it is not statistically significant. Okay, so then you have to accept the null. Okay, so what is the null? Okay, so there is no difference. Okay, there is no significant difference between the sample mean and the population mean. Okay, so that is how you have to interpret. Okay, but again I am going to do the same thing, but with I am going to apply the higher hypothesis mean. Okay, so and we are going to check what will be whether the probability value is significant or not. Okay, so I'm going to do the same thing. I'm going to analyze compare means. Okay. So within that, you have to select the one sample t-test. Okay. Here hypothesis mean. So I'm going to put, okay, 50. Okay. So then I'm clicking OK. So now you can able to see the probability value. Okay. It is less than 0.01. Okay. If you check it in the percentage, okay, it will be less than 1%. The error is 1%. Okay. Less than 1%. Okay. So then you can able to reject the null hypothesis. Okay. So you can able to reject the null hypothesis. Okay. So there is a significant difference between the sample mean and the hypothesis. Okay. So hope it is clear. I'll take some 5 minutes break. Then I'll continue for the next session. Is that okay?
Yes, sir.
Yeah. Okay. I'll take 2-3 minutes break. So then I will.
Okay, sir.
resume.
Okay, sir.
Yeah. Thank you.
Yes.
So shall we resume the session?
Yes, sir. Sure.
Yeah. Thank you. So as I said that the t-test. Okay. So we will be having a question that. So are we need to consider only the t-test for only small samples? Okay. Okay. So the answer is no. Okay. So even if you run the t-test, okay, so for more than 30 samples also, it will be considered. Okay. So now we are moving to the independent t-test. Okay. So first we have seen the one sample t-test. Now we are moving to the two sample or independent sample. The name itself independent sample. Okay. So two different samples. Okay. So in the first case, we are relating the sample mean with the population mean. Okay. But here, two of them are samples. Two of them are sample, but these two are entirely independent. Okay. So, but ultimately the intention is to compare the means only. Okay, mean comparison. We are going to compare the means. Okay, so that is the thing. So here also we will be having certain assumptions. Okay, so like whether the data is normally distributed or not. Okay, so followed by we'll be having the assumptions of homogeneity of variance. Okay, so here in this case, okay, the homogeneity of variance will be applicable. Okay, homogeneity of variance, okay, is applicable in the case of two sample test, because so when you're having two samples, then it is applicable. If it is only one sample, okay, so the second assumption, that is homogeneity of variance, will not be applicable. Okay, so third and fourth, okay, it is not based on the strata, it is based on the researcher. He has to decide whether that your data is following these assumptions or not. Okay, so then independent sample t-test. Okay, so in the case of earlier case, that is one sample t-test, we know that x bar minus mu. Okay, so divided by standard deviation square root of n. Okay, but here the formula is different. Okay, so x1 bar minus x2 bar. Okay, so what is meant by x1 bar? So x1 bar is nothing but it is the mean of the first group. Okay, so first sample. Okay, so I am going to, so for example, I am going to give a scenario called, okay, so I'm just this coming here. I'm going to give a scenario. Okay, so I am having two different types of car. Okay, so one is domestic car. So another one is exported car. Okay, so respective miles per gallon I am having. Okay, so my intention is to check whether is there any difference between the mean of domestic and the export cars. Okay, so mean of MPG, okay, miles per gallon. Okay, so this is my objective. So in this case, you can't, so in this case, you can't able to use the one sample t-test. Okay, so because I am having two samples, sample one is domestic miles per gallon, second sample is exported cars miles per gallon. Okay, so then you have to go for the two sample t-test. Okay, so then you have to frame the null and alternate hypothesis. Okay, null hypothesis is there is no relation or no difference. Okay, so there is no difference between the domestic and exported cars. Okay, then whether it is a two-tailed or one-tailed. Okay, it depends on the researcher. Okay, so if it is two-tailed means, so simply you can able to put that there is a difference. Okay, the difference may be positive or negative. So if you are mentioning only one direction, then it is one-tailed test. Okay, so then you have to apply the two sample t-test. Okay, so this is the formula. So x1 bar is nothing but it is the mean of the exported car miles per gallon. Second, mean of the domestic cars miles per gallon. So then this is the standard deviation. It is not normal standard deviation. It is the pooled. Okay, so it is combined standard deviation because separately we are not keeping. Okay, it is a pooled standard deviation. Okay, then 1 divided by n plus n1 plus 1 divided by n2. So n1 and n2 are nothing but number of observation. Okay, so this is the formula. Okay, even we can able to do it in the Excel itself. Okay, so using the formula, okay, you can able to manually, okay, you can able to calculate. Okay, or even in SPSS also you can able to do manually, you can able to calculate. Otherwise, you can able to do menu driven or syntax based. Okay, syntax based also you can able to calculate. Okay, so here you have to know that these are the assumptions. So this is the main thing. So we have to check the homogeneity of variance, whether the variance are equally distributed among the groups or not. Okay, so then independence and the interval test will be there. Okay, so if this assumptions is not satisfied, then we have to go for the Welch test. Okay, so Welch test is there. So what in the t-test we can't able to do. So in the ANOVA we'll be seeing this Welch test. Okay, so first I'm going to use the data. Okay, so I'm just opening the data. So for example, I am going to do the 2 sample t-test. Okay. So 2 samples will be there. One is type, another one is miles per gallon. Okay. So I am going to close this SPSS. Okay. So I am going to open it again. So as I said that I am having 2 different types. Okay. So in the data, sorry, variable view, I'm just typing type. Okay. So followed by I'm typing the miles per gallon. So then it will be displayed. Then I have to copy and paste the data. Okay. 10 means, okay, 1 means it may be imported. Okay. 0 means it is the domestically produced car. Okay. So what I have to do? So I have to test the assumptions. Okay. So for example, I'm just checking only the homogeneity of variance. Okay. So for example, for that I am going to analyze. So within that you can do it 2 ways. One is t-test. Okay. Other way is ANOVA. Okay. ANOVA will say that, okay, whether the data are the data's variance are distributed normally among the groups or not. Okay. So I'm just clicking the one way ANOVA. Okay. It will be saying that what is your dependent variable? My dependent variable is, so before that you have to check it. Okay. So this type is a qualitative variable. Okay. Or we can able to say that it is the nominal data. Okay. So it's not ordinal. So nominal in the sense, so generally it will be 0 or 1 only. Okay. So then what you have to do, go to analysis. So compare means, so I'm just checking the assumption of variance. Okay. I'm just clicking the miles per gallon. Okay. Type I'm just selecting here. Okay. So then in the case of option, okay, you have to select the homogeneity of variance because that is our aim to check the homogeneity of variance. Okay. So if the test is insignificant, then we can able to accept the null hypothesis. We'll see the results. Okay. So here you can able to see that F test will says about the variance. Okay. So the value is insignificant. That is 0.26. So if you are converting it into percentage, it is 26% of error. Okay. The error should be less than 1% or less than 5%. It is acceptable. Okay. But here it is insignificant. Due to that, we are accepting the null hypothesis that the data are distributed homogeneously. Okay. The variance of the data are homogeneous. Okay. So followed by what I'm going to do, I'm going to run the, we know that the remaining 2 assumptions, okay, the data is independently distributed. On the other hand, it is measured in the scale, either it is a interval or ratio. Okay, first assumptions also it follows. Okay, so then I'm going to test the 2 sample t-test. Okay, so for that what I have to do, analysis, compare means, okay. So independent sample t-test. Okay, so I'm just selecting the independent sample t-test. Okay, so here you have to select the test variable. Okay, so followed by you have to give the group variable. So here you have to define the group. Okay, so I'm having 2 groups. One is 0, another one is 1. Okay, so then I have to click the OK. So we are getting the results. Okay, so then what we have to do, we have to export the data. So our results. Okay, so I'm going to export. Okay, but now I'm going to export in the Word document. Okay, so I'm just exporting it in the Word document. Okay, so instead of 1, I am just typing 2t. Okay, 2t in the desktop. Okay, so I am opening the 2t. Here you will be seeing the results. Okay, number of observation. Okay, for MPG is domestic car is 6 and the exported car is 6. What is their respective means and their respective standard deviation, standard errors. Okay, so followed by you will be having the F value. Okay, so Levene's test will tell us about the equality distribution. Okay, so if it is insignificant, okay, so if this value is insignificant, okay, so that is 42%. Okay, so it is greater than 1 or 5%. Okay, so we have to accept the null. So the null is nothing but, so it is the equality of variance. The variance are homogeneous. Okay, so then but that is not our intention. Okay, our intention is to check the T. Okay. So T tells about the mean difference. Okay. So mean difference between the two groups. Okay. So one is imported cars. Another one is domestically produced. So whether the miles per gallon is okay, the mean is different or not. Okay. So here you can able to see that the T statistics is 1.174. Okay. So on the other hand, the degrees of freedom is different for equal variance and if it is unequal variance. Okay. So followed by you can able to see the equal variances. So if it is equal variance, you can able to see that the significant is 0.268. Okay. It is 0.268. Okay. So that means that 26% significant. Okay. So the probability value is 26%. So directly we can able to reject the null hypothesis. Okay. So why we are rejecting the null hypothesis? Okay. Because there is no that much significant difference between the two groups. Okay. So even though here you can able to see that 23 minus 21. Okay. So even though there is a difference, but it is not statistically okay significant. Okay. So that's how we have to interpret the results. Okay. So far we have seen two different tests. Okay. So now we are moving to the paired sample t test. Okay. So I'm just quickly. Okay. So now we are moving to the third case. So Welch test. So generally when the variance are okay, variance assumptions are not met. Okay. So as I said that the data should be homogeneous variance. Okay. So it is based on the Levene's test. Okay. So if it is not met, then we have to use the Welch test. Okay. So I'll show how to do the Welch test. Okay. So now we are moving to the so I'll do the Welch test later. Okay. So now we are moving to the paired sample t-test. Okay. So this is also t-test. Okay. T-test itself comparing the means only. Okay. But in the case of one sample, we have to go if we have only one sample, okay, then we have to go with this one. So we are comparing the sample mean with the population mean. Okay. So in the second case, two sample, it is not about the population. It is the difference between the two samples. Okay. Whether the sample one is different from the sample two. Okay. Third one is paired sample. Okay. So paired sample. So here we will be having, so before and after. Okay. Same sample before and after we will be using. Okay. So same sample before and after. Okay. So for example, before giving the training, okay, or before giving the some medicines. Okay. So but you have to note that here it is same sample, but in the two sample, it is the name itself, it is independent sample t-test. Okay. So now we are going to do this one independent or paired t-test. Okay. So I'm just opening the Excel sheet. Okay, paired t-test. So I'm having two different miles per gallon. Okay. So I'm just closing here. I'm typing it. Okay. So the data arrangement is different. Okay. So you have to do the data arrangement. Okay. Differently. Okay. In the earlier case, in the two sample t-test, we are having a variable called a type. So within that, so we are having two different groups. Okay. But in the case of paired sample t-test, okay, so we should not having a group variable. Okay. So MPG2. Okay. So I'm just mentioning these two things. Okay. And I am moving to the data. So I'm just copying the data. And I'm pasting the data here. Okay. So then you have to do the checks. Okay. So normality assumptions, homogeneity of variance. Okay. Independence of variance observations. Followed by the scale test. If those assumptions are satisfied, then directly you can move to the analysis. So then compare means within that you can able to see that paired sample t-test. Okay. So you have to select two pairs. Okay. MPG1 and MPG2. Two samples you have to select. So here you can able to see the options and all other things, and you have to click OK. Okay. So now I'm going to export the data file. Okay. Here you can able to see that export. Here I am going to save it as parity. Okay, parity test. Okay. So I'm just clicking OK. So here also the intention is nothing but, so we are going to see before and after approach. So for example, I am putting some additives, okay, additives in the petrol or fuel, okay. So same car I am having, after the additives and before the additives, is there any change? Okay, so the mean of miles per gallon has any change due to the additives in the fuel. Okay, that is the intention or objective. Okay, so as we know that the miles per gallon. Okay, so in the first case the mean is 21. The second case the mean is 22.75. So you can consider it is before and this is after. Okay, so number of observation is 12 because it is the same sample you have to take. Okay, so then respective standard deviation. Then they have given the number of observation correlation. So correlation, so here you can able to see that it is 0.037. Okay, so it shows that there is a significant difference. Okay, but it is not our intention. So here you can able to see that what is the mean difference. So the mean difference between MPG1, okay, minus MPG2 is minus, okay, 1.750. So there is a difference. Okay, so when this is the before case, for example, it is 20 miles per gallon. Okay, so in this case it is 21 means. Okay, so there will be some negative difference you will be getting. So that's why they have mentioned that minus 1.75 is the mean difference between miles per gallon and miles per gallon 2. Okay, so respective standard error. Then we are moving to the difference. Okay, paired sample t-test before and after. Before and after, is there any difference or not? Or okay, so because of the additives, okay, whether it has created a change in the mean. Okay, so here you can able to see that the significance says that 0.46. Okay, sorry, 0.046. Okay, so if you are converting it into percentage, it will be around 4.6%. Okay, so as per the social science, up to 5% we are allowing the errors. Okay, the probability of error can be allowed up to 5%. Okay, so it says that there is a significant difference, statistically significant difference between the two means of groups. Okay, that is before and after. When you are adding some additives, it is giving some significant difference. Okay, so it is said to be the parity test. Okay, so this is how you have to interpret the parity test. So now we are moving to other categories. Okay, so this is the way. Okay, so you have to go to analysis, compare the means, paired sample t-test. Okay, so if the probability value is less than 5, that is 5%. Okay, so the probability of error. The probability of error is 5%. Then you can able to say that there is a significant difference between the paired means, that is before and after. Okay, so because of the additives in the fuel, okay, so there is a change. Okay, so that's what. So you have to check whether it is positive or negative. Okay, it depends. Okay, whether it is a one-tailed or two-tailed. It depends. Accordingly, you have to prove or disprove your hypothesis. So now we are moving to the F test. Okay, as per the inception. Okay, so 1908. So they have introduced the T test. Okay, so far we have seen the T test. So now we are moving to the F test. Okay, so the F-test, even though F-test was introduced during the year 1920s, okay. So the name of F-test was came during the year 1930s only. It was given by George, okay. So to honor the Fisher, okay, to honor the Fisher, okay. So he has given this name as a F-test, okay. So this is as per the inception, okay, F-test, okay. So F-test during the year 1930, so they have named it as F-test. So to honor the Fisher, okay, R.A. Fisher. So as I said, the T-test is used for comparing the means, mean comparison. But in the case of F-test, okay, F-test is used for comparing the variance. Okay, to compare the variance, so we will be using the F-test, okay. So this is the formula, okay. F is nothing but, okay, F-test, F statistics is nothing but S1 square divided by S2 square, okay. So this is the formula. So S1, we know that it is the standard deviation, okay. S is nothing but standard deviation. S is nothing but standard deviation, okay. S square is nothing but variance, okay. Or we can able to say that square root of, okay. So when you are taking the square root of this one, so automatically you will be getting the variance, okay. So that is the relationship, okay. So S square is nothing but it is the variance, okay. So variance of the first group divided by variance of the second group, okay. So that is how we are calculating the F statistics. So what is the F statistics? As I said that, so there is a difference between the statistical test and statistical methods, okay. So in this case, F-test is the statistical test. When we are using this F-test, okay, in the ANOVA, it is said to be, the ANOVA is a method, it's not a statistical test, okay. So that's why they are saying that the F-test is the most commonly encountered in the ANOVA, okay, analysis of variance. Generally, we will be using this one. So if test were means of two or more independent groups, okay. So two different groups are there, okay. It is not paired, okay. So it is said to be the independent group, okay. So are significantly different. So we will be intentionally, we will be covering the variance between the groups, okay. So F-test is for variance, T-test is for means, mean comparison. This is the variance comparison, okay. So the group variance, okay, within the group, okay, and the between the group. So you have to note that in the case of SPSS, okay, so there is no separate menu, okay. So for F-test, okay, so directly we have to do the ANOVA, okay. From the ANOVA, we have to do this one, okay. So as I said that, so in the case of T-test, separately we are having menu called, okay. So one sample T-test, paired T-test, okay. So independent sample T-test like that, okay. But in the case of F-test, we won't have separate menu called F-test, okay. So even though we can able to calculate the F-test, okay. So even though we can able to calculate the F-test using some methods, I'll be showing how to calculate the F-test in the SPSS, okay. So before that, you need to know that as in the case of Stata, even in the case of SPSS also, we are having the menu syntax based, okay. So you can able to type the command and you can perform the command and you can able to get the results, okay. So for example, I am just showing it here, okay. So this is the result we already got, okay. So I'm just copying this command, okay. This is the command, okay. T-test pairs which is equal to mpg1 with mpg2, okay. So I'm just copying this one, okay. So I'm just closing this entire results, okay. So now I'm going to use the syntax, okay. So using the syntax, I'm going to run the T-test, okay. So how to do? So you have to click the file, okay, then new, then syntax you have to, and you have to paste, okay. So if you are good at command, okay, then you can type the commands, okay. So otherwise, so this is for your okay, this is for your knowledge, okay. So I'm just selecting the data, comments, and I am clicking this green color symbol, that is run, then you will be getting the results. Okay, you can able to do it in two ways. Okay, either you can able to do menu driven, otherwise you can able to type the command in the syntax and you can able to perform the analysis. Okay, so with this, so I am just moving to the F test. Okay, so how to do the F test? Okay, as I said that there is no separate menu in the SPSS. Okay, so I'm just closing this one. Okay, now I am going to perform the F test. Okay, so for that I am going to take the data. Okay, so I'm having miles per gallon 1 and miles per gallon 2. So I'm going to check the variance are same or not. Okay, so with the, is there any difference between the variance or not? Okay, that can be captured from the F test. Okay, so as I said that the T test is for mean comparison, F test for variance comparison. Okay, so I'm just closing here. I'm just typing the variable name. Okay, miles per gallon 1 and miles per gallon. Okay, MPG 2. Okay, so then what you have to do, you have to copy paste the data. Have to copy paste the data. Just pasting the data here. Okay, so then what you have to do, firstly you have, so I'll be showing the formula. Okay, based on the formula, okay, we are going to compute it here. Okay, same thing we are going to compute from the, okay, what is the formula? So formula is nothing but summation of xi minus x bar the whole square. Okay, sorry, s1 square divided by s2 square. So s1 and s2 are nothing but it is the variance. Okay, so we know that these two are variance. Okay, so firstly I need to know the variance of these two. Okay, the ratio between the two variants are said to be the F test. So how to calculate the F test? For that, what I have to do, I have to firstly I have to compute the so first I have to get the, for example, I have to go to analysis. So descriptive statistics. Okay, so within the descriptive statistics, I am going to select two variables. Okay, so here you can able to see that variance is there. Okay, so I need this variance. Okay, so then I am clicking OK. Okay, so now I got the variance. Okay, so what is the variance? So variance is 7 point something. Okay, so the variance is 7 point something, and for this is the first group and this is the second group. Okay, so I'm just saving it in exporting. Okay, so here I am just changing it to F. Typing test, F test. Okay, and I'm clicking OK. And I'm opening it here. Okay, so this is the variance. Okay, so we know that the F test is nothing but, okay, F is nothing but, okay, S1 square divided by S2 square. Okay, so S1 is nothing but it is the variance of first group. Okay, this is the variance of second group. Okay, so here you need to know that when you are calculating the F test, okay, so the numerator should be greater variance. Should be the greater variance. Okay, so as per this case, so here you can able to see that this is 7 point, this is 10 point. Okay, so the miles per gallon, so variance of S1 square is nothing but, okay, MPG2 variance divided by S2 2. Okay, that this is MPG, okay, 1. Okay, when you are dividing these two things, okay, so automatically you will be getting that. For example, I am just copying and I am pasting it in Excel. Okay, so equal to, so this divided by this one. Okay, so this is said to be the F statistics. Okay, F calculated value. Okay, So F calculated value, then you have to calculate the F table value. Okay. So when your calculated value is greater than the table value, then only it is said to be the significant. Okay. Otherwise it is not significant. So then how to calculate this one in the SPSS? Okay. So for that, what I have to do, okay, I'm just minimizing. Okay. And I am moving to the SPSS. Okay. So here what you have to do, you have to compute the F value. Okay. So how to calculate the F value? So here we have to click the transform and compute variables. So here I am typing the F underscore value. Okay. So as I said that even in SPSS also we can able to use the command. Okay. So as in the case of Stata or RStudio, so we can able to use the commands in the SPSS also. So here I am going to type the mean values. Okay. So what is the mean value? So we know that the mean value is nothing but, okay, so 10. Okay. So 10.568. Okay. So then minus, sorry, not minus, divided by, okay, so divided by 7.455. Okay. So if you click OK, so the F values are computed in the actual data. Okay. So here you can see in the actual data, you can able to see that the F value is 1.42. Okay. So this is the calculated value. Okay. Then I have to do the table value. How to calculate the table value? Okay. So again, what you have to do, you have to go to transform. So compute variables. So instead of F value, okay, you have to calculate that. Okay. So probability value. Okay. So to avoid the time, okay, so I'm just copying it here. So you have to compute the probability value. Okay. Here you have to paste the command. Okay. So 1 minus CDF.F. Okay. So then here you have to give the F value. What is the F value? So the F value is nothing but, okay, 1.42. Okay. Then the degrees of freedom, because n minus 1. So here 12 observations are there. Okay. N minus 1 and n minus 1. Okay. You will be getting the values. Okay. So now the probability values are computed. Okay. So here you can able to see that automatically the probability values are computed. The probability value is 0.29. Okay. So it is said to be the insignificant because 29% of error is there. So due to that, we are not accepting the null hypothesis. Okay. So the null hypothesis, we know that. Okay. So the null hypothesis is nothing but there is no variance. Okay. Between the groups. Okay. So the alternate hypothesis is there is a variance, but the probability value is significant. So if it is significant, we have to accept the null hypothesis. There is no significant difference. Okay. Is not there in the variance. Okay. So that's how we have to do the F statistics. Okay. So now we are moving to the final case, that is Z statistics. Okay. So yeah. So this is the major thing. Okay. So most of the formulas are same. Okay. Formula are same for both Z and T statistics. Okay. So here you need to note that Z statistics, okay, it is not used. Okay. So it is rarely used. Okay. Why it is not rarely used? Okay. So we know that both Z and T test are used for comparing the means. Okay. So on the other hand, we know that T test is for, okay, less than or equal to 30 samples. So here it is more than 30 samples. We will be using the Z test. On the other hand, T test will be used, okay, when your standard deviation is unknown. You don't know the standard deviation. Okay. But in the case of Z statistics, so the standard deviation is known. Okay. That is the assumption of Z statistics. Okay. But in the real world situation, we can't able to know the standard deviation of the population. Okay. Population standard deviation is difficult to get the values. Okay. So due to that, in most of the cases, the Z statistics will not be used. So even I have shown it in the statistical methods. Okay. So you can able to see that even in the methods also, they are not using the Z. Okay. So either they are using T or F. Okay. So they are not using the Z statistics. That's why they are saying that. Okay. So it is used rarely. On the other hand, you are going to see the basic difference between the Z statistics and T statistics. Okay. Because F is entirely different. So it is used for comparing the variance, okay, between the two groups. Okay. So on the other hand, Z and T test are more or less same. Okay. But the thing is, Z test is rarely used. Why it is rarely used? Because we don't know the population standard deviation. Okay. When the population standard deviation are known, then only we can able to. So because that is the formula. I'll be showing the formula for Z test also. Okay. So when you know the population standard deviation, then only you can able to use the Z test. Okay. Otherwise, you have to go for the T test. Okay. So as I said, that the advantage is, so even the sample size is more than 30. Okay. You can able to use the T test. Okay. So due to that case, so most of the statistical methods, they are using the T test. Okay. So the basic difference is population standard deviation, that is sigma. Okay. Here we will be using the sample standard deviation. Okay. Sample standard deviation. So here the distribution, so it follows the normal distribution. Okay. So the Z test follows the normal distribution. Okay. But in the case of T test follows the T distribution. Okay. F test follows the F distribution. Okay. So in the case of Z test, this is the main difference between the formulas. Okay. So in the Z test, they won't include the degrees of freedom. Okay. So why they are not including the degrees of freedom? Because it is difficult to identify the entire population. Okay. So when you are not able to identify the entire population, automatically this degrees of freedom will not be applicable, okay, for calculating the Z test. But in the case of T test, it is for sample only. Okay. So it is easy for us to calculate the sample, whether it is 30, 300, 400. So from that, we can able to do n-1, automatically we can able to calculate. Okay. So here you can able to see that sigma is nothing but standard deviation. So standard deviation is required in the case of Z test. Okay. So in the case of T test, it is not required. Okay. So it is not required for calculating the T test. But if you are calculating the Z test, so the standard deviation is known. Okay. That's why we are saying that it is rare. Z test is rare. Okay. So that is the basic thing. So this is the formula. Okay. So Z test, so is equal to x bar minus mu naught sigma divided by square root of n. So even if you are comparing with the T test also, okay, x bar minus mu naught divided by sigma. So here we have mentioned here. So even we can able to write it here also. Okay. So there is no difference. Then where is the difference? So the difference came when the degrees of freedom. Okay. So in the case of Z test, the degrees of freedom will not be considered. Okay. But in the case of T test, so the degrees of freedom, okay, which is equal to n-1. Okay, if you are having 30 observation minus 1, which is equal to 29, will be the degrees of freedom. So then we can able to calculate, if we calculate where we have to use this degrees of freedom for calculating the probability value. Okay, so there only it will there is a change. Okay, so even we are having the same cases for two sample Z test also. Okay. So there also we will be using the same formula, but the change is only the degrees of freedom. Okay, will not be applicable in the case of Z test. Okay, since it is for population. Okay, so if it is for population, okay, when we don't know the population, automatically the degrees of freedom will not be applicable in the case of Z. Okay, but in the case of T test, the degrees of freedom will be applicable. Okay. So that is the basic difference. Okay, that's what the case of Z test. Okay, Z test was given by RA Fisher. Okay, even in the case of F test. Okay, so as I said that George. Okay, to honor the RA Fisher. Okay, at the initial period, so it doesn't mean that Fisher F test. Okay, so later 1930s only. So they have named it as a F test. Okay, to honor the Fisher. So these are the assumptions. Okay. So I'll just give a summary, okay, so that it will be helpful for you to have some. Yeah. So as I said that in this parametrical test, okay. So statistical test. So within that we have seen that parametrical test. Okay. So within that parametrical test, so we know that it should follow some assumption. Okay. So I'm just summarizing. Okay. So what are the assumptions? So assumption one is normality assumption. Okay. So followed by homogeneity of variance. Okay. So followed by it should follow the independence of observation. Then it should follow the scale. Okay. Either it should be the scale of interval or it should be the form of ratio. Okay. So then once we have decided, we will be having three different types of test. Okay. One is t test. Okay. Second one is z test and f test. So these two are used for comparing the mean. Okay. So this is for variance. Okay. So then t means, okay, why when we have to use t and when we have to use z. Okay. So t can be used for, okay, less than 30 samples. Okay. So on the other hand, even we can able to use more than 30 samples also, it is not going to make any issues. Okay. So but in the case of z test, so it is greater than 30 samples. Okay. So it follows t distribution and it follows the normal distribution. Okay. So it follows the f distribution. Okay, so then t distribution, so t test has three categories. One is one sample, okay, so two sample, so followed by paired sample. So even we can able to classify z also one, two, and paired. But z is rarely used, or most of the cases z test will not be used. Okay, so only t and f test will be used. Okay, so on the other hand, what is one test? So here we are comparing the means of sample mean with the population mean. Okay. So in the two sample, the name itself independent t-test or two sample, two different samples we will be having. Okay. So we are going to see the mean comparison between the two samples. Sample one is, okay, equal or not equal to the sample two. Okay. Mean difference. Okay. So in the case of F, so we will be going to cover the case of variance difference. Okay. Homogeneity of variance are not are, okay, are present. Okay. So the formula is nothing but S1 square divided by S2 square. Okay. Here the thumb rule is, so you have to put the higher variance in the numerator. Okay. So that is the case. Okay. So for this is the summary cases. Okay. So is that test? So who gave this one? Ronald A. Fisher. Okay. So it follows the normal distribution. So ultimately it will be used for comparing the means. Okay. So it is used for larger samples. So but rarely it is used. So one sample t-test, William Gossett. So generally all the three are said to be the student t-test. So I have given the reason for why it is called as student t-test. So it is comparing the sample mean with the hypothesis mean value. Okay. So for example, 30, 50, whatever it is, you can able to give. Okay. So here in the case of Gossett, so Gossett t-test, this is for two sample when you are having two different samples. Okay. So to compare the means of two independent groups, then you have to use the independent sample t-test. Okay. So n should be less than 30. So even we can able to use more than 30 also. Okay. Similarly, this is the case of paired sample t-test. Paired sample t-test. So same sample we have to compare. Okay, before and after. Okay. So finally F test. So F test, as I said that it is comparing the variance or means of three or more groups. Okay. So even two groups also we can able to do. But if it is ANOVA means it is three groups. Okay. So if it is only F test, okay, so we can able to do it for only two groups. Okay. So with this, I am resting my presentation. So I am expecting your queries. So I am happy to address your queries. If you have any queries, kindly let me know.
Sir, okay, sir. Thank you, sir.
Yeah.
The session is open for discussion. Participants, if you have any queries, kindly come forward, unmute yourself and go on. Sir, there is few
Yeah.
questions in the chat box also. So
Yeah. Okay. I'll have a look on it.
sure, sir.
So the first question is we test for normality if normal, then we test for homogeneity using independent sample t-test. So if not, then what we have to use the Welch test or not. So it is very simple. So as I said that we don't need to satisfy all the assumptions. Okay. So for example, I'll show it here. I just copy. So as I said that there are 4 assumptions are there. Okay. So normality. Okay. So mainly when we have to use the normality. Okay. So when your observation is less than 30 sample, okay, then only you have to choose the normality test. Okay. That means that if it is not satisfy the normality test, then only you have to move for the non-parametric test. Okay, so even though the normality assumptions are not satisfied, but your observations are greater than 30 samples. Okay, so then the central limit theorem, it will take care of the assumption of normality. So then you don't need to care about this normality assumption. So when your sample size is more than 30. Okay, so on the other hand, some assumptions are defaultly will not be applicable. For example, the second assumption is homogeneity of variance. Homogeneous of variance. Okay. So in that case, okay, for example, if you are running a one sample t-test, okay, so automatically this will not be applicable. Okay, because so we are having only one sample. Okay, so in that case, we can't able to find the between group variance. Okay, between group variance will not be applicable. Okay, so due to that, so we can't able to satisfy all the assumptions. Okay, some liberal things are there. Okay, so for example, as I said that if you are having more than 30 samples, okay, you don't need to worry about this normality assumption. Okay, so but if it is 30 samples, less than 30 samples, okay, then it is a serious concern. So then you have to move for the non-probability sample. You can't able to use the probability sampling. So then from the independent t-test, okay, can we able to identify the positive or negative correlation? Yeah. So, but here you need to know that what is the use of t-test. Okay. So t-test, okay, to test the compare the means. Okay. So if your objective is to compare the means, okay, so you can able to either use t-test, okay, one sample t-test, okay, 2 sample t-test or paired t-test according to your data as well as objective. But your objective is, okay, to test the correlate, to check the relation. Okay. So if your objective is to check the relation, okay, either it is positive or negative. Okay. So in that case, okay, you have to move for the correlation analysis. Okay. So for example, if your objective is to see the impact, okay, so then you have to move for the regression. Okay. So based on your objective, you have to select the test. So then, so the answer is for the independent t-test, okay, can be able to identify the positive or negative correlation. So relation cannot be identified, but you can able to see whether if it is a one-tail test or two-tail test, that can be captured from your results. So then sir did not understand that when significant and when not. Okay, so it is very simple. Okay, so whatever statistics you are using, okay, so non-parametric test, okay, so just come here. So for example, it is the most of the people will be having this question. Okay, what is meant by significant? Okay, how to calculate the significant? So the thumb rule is, okay, less than 0.01 is said to be the 1% significant. Okay, so then 0.01 to 0.05 is said to be the 5% significant. Okay, so what is meant by 0.01? So I am just converting it into percentage. 0.01 into percentage means 1%. Okay. So 0.05 means 5%. Okay. So since we are from social science, okay. So up to 5% errors can be considered. Okay. So, but in the case of medical science, okay, so they will be considered only 1% of probability of error. So this is said to be the probability of error. Okay. So allowable probability of error is 1%. That means that 99%, 99%, your result will be correct. Okay. So only 1% of probability of error. That means that, so for example, you are saying that, so the mean difference between male and female, okay, so it may be income or it may be sugar level, heartbeat, okay, whatever it is, okay, some parameters you are having, okay, or income, okay. So you are going to compare the means of male and female, okay. So here you are saying that your result is, okay, your result is saying that there is a difference of 2.5 something, okay. So the mean difference is this much amount, okay. So you are saying this result, okay, also the significant is 1%. That means that the probability value is 0.01. Okay. So in that case, so you can able to input the result that, okay, 99%. So my result is correct. There is only 1% of probability of error being wrong. Okay. That means that there may be, okay, so maybe 0.1, okay, or it may be 0, okay, we don't know. That is said to be the error, okay. So 99, the significant is 1% means 99% your result is correct, okay. So that is the basic thing you need to know, whether it is a whatever test you are using, okay, you have to know this one, statistical, how it is statistically significant or not, okay. What about the Welch test? So Welch test, so it is mainly used for the variance, okay, when the variance are, okay, not equal. Okay, so I'll just discard it here. Just discard and I am opening it again. Okay, so what about the Welch test? Okay, so Welch test mainly it is used for checking the homogeneity assumption. Okay, so as we know that, okay, so there are different tests, different assumptions are there. Okay, so one is homogeneity, first one is normality. Okay, so second one is homogeneous of variance. Okay, so and the remaining third and fourth assumptions are there. Okay, so for checking this assumptions, okay, so we will be using this Welch test. Okay, Welch test. Okay, so in between it will be providing that whether the variance are homogeneous or not. Okay, so if it is homogeneous means variance are equal. Okay, equal variance are there. Okay, so if variance are not equal, okay, so if the variance are not equal, then only we have to use this Welch test, okay, for calculating the F statistics. Okay, so if your variance are not equal, okay, but you want to calculate the F statistics, okay, then you have to go for the Welch test. Okay, so I'll show it here. Just discarding. Okay, so here you have to go to analysis. Okay, so compare means, so here you have to select the one-way ANOVA. Okay, so actually here we should have the factors. Okay, so just, okay, so as of now I'm just mentioning here. Okay, comparing the means. Okay, so then one-way ANOVA. So actually you have to give your dependent variable and your factor should be here. Okay, you have to give the factor, but due to paucity of time, I'm just mentioning it as MPG2. Okay, so here it should be male or female, imported or exported cars, whatever it is. Okay, two different categories you have to give. Okay, so in the option here, you have to click the Welch test. Okay, so why we have to click the Welch test? We are assuming that the variance are not equal. Okay, then only we have to click this test and you have to run the ANOVA. Okay, then you will be getting the results. Okay. So also I just want to mention that whatever test you want, you can able to do the same thing in the Excel also. Okay. So for example, if it is a 2 sample t-test. Okay. So for example, this is the 2 sample. Okay. So these are the 2 samples are there. Okay. If you go to data and data analysis. Okay. So here you can able to see that you can able to see different test. So t-test paired 2 sample. Okay. So here t-test 2 sample assuming equal variance. So equal variance means okay, normal t-test we can able to do. So if you want to do unequal variance means automatically it will go to Welch test. Okay. Similarly, you can able to see the variant F test, F statistics you can able to do. Okay. So just for your understanding, I'm just showing it as 2 sample t-test. Okay. I'm just selecting. Okay. Here you have to select the so as I said that here the data arrangement is different. Okay. So the data arrangement is different. Okay. So for if you are running it in SPSS, the data arrangement is different. Okay. How we did. Okay. So here you can able to see that parity test. Okay. So MPG1 and MPG2. But if it is in the case of here, okay, I'll be showing here. So data, go to data. So you have to click there and you have to select the type 1. For example, I'm just selecting MPG1. Okay, I'm not going to change here and MPG2. Then you have to click the labels and output range where you want. Then you have to click the output here and you have to click the OK. So here it will be showing that what is the mean difference between the 2 groups. Okay, so mean is 22 for the first group. Second group is 22. Okay, so then variance it was given. So then in between they have given the hypothesis mean is 0. That means that there is no significant difference between the 2 things. Then here you can able to see that one-tail t statistics and the two-tail statistics. Okay, so accordingly you can able to calculate. So here you need to note that. So how to calculate the so here this is the calculated value. This is the calculated value and this is the actual value. Okay, so this is the probability value. So the probability value. So if you are clicking percentage, okay, so for example home, and if you are clicking the percentage, so it is showing that 91%. Okay, so we know that we will accept only 5% error. Okay, here the 91% of error. Okay, so you can't able to say that there is a significant difference. So even though there is a difference between MPG1 and MPG2, this is 22 and this is 23. Okay, but we can't able to say that it is the significant difference between the 2 groups. Okay. So then in one sample t-test, difference of mean between the sample and the population. But how do we know the population? Yeah, that's what it is hypothetically. What you have mentioned is correct. Okay, so it is hypothetical mean. Okay, you are comparing one sample means. So you are having the sample mean with the hypothesis population mean. So in case of paired t-test, okay, for before and after. So to suppose if we have zeros in the before data, no, 0 we should not consider. Okay, we should not consider 0. So you have to leave the data. Okay, if you put 0, then it will change the values. So that if you are putting, for example, 50 and 0, so the average will be 25. And 50, so if you are putting 50 and leaving 0, okay, then the average will be the same. So in testing the t-test to find the t-test. So in testing the t-test to find means, you have used 2 different types. Okay, 20 and 30. So these are all hypothesis mean. So in the testing t-test to find the means, yeah, first we have to do the descriptive statistics. So from the descriptive statistics only, I came to know the values of the mean. Then I am comparing that mean with the hypothesis mean. Yeah, hope I have addressed all the queries. So There are any queries? Kindly let me know.
Dear participants, if you have any doubts, please ask. You can unmute yourself and ask the questions if you have. Sir, I guess there is no more
Yeah.
questions. I would
Okay,
say.
okay. Yeah,
So
thank you.
if there is no more doubts, we will winding up the session. So
Yeah,
thank you, sir, for the wonderful and insightful session. The lecture was very clear, very simple, and highly informative. You have explained many parametric tests which can be utilized in research to get reliable research. And thank you once again, sir, for the very much informative session.